All right, Unit 7, Worksheet 3, Homework 3. Mr. Trutna here, coming to you live, November 21st, 2019. Let's get going. So what we're going to be doing is we're incorporating the idea of the trigonometry, the ratios, and we're going to be finding the missing sides. Okay, so in most of the problems, what we're going to be referring to is we're going to be referring to the fact that the sine is equal to the opposite leg over the hypotenuse. The cosine is equal to the adjacent leg over the hypotenuse, and the tangent is equal to the opposite leg over the adjacent leg. Okay, so in number 1, it says give each trig ratio as a fraction in simplest terms. Okay, so what we're going to do is, so before we can do number 1, notice we have side P to R is 14, side R to Q is 50. First thing we have to do in number 1 is we have to find side P to Q. Okay, so I'm going to call that x right there, and I'm going to use Pythagorean Theorem to figure out how long it is from P to Q, because what I need to do is I need to write the ratio. In other words, that's just a fraction, but before I can do that, I'm going to have to know how long all three of the sides are. So I'm going to use a squared plus b squared is equal to c squared. That's the Pythagorean Theorem. Remember, c represents the length of the hypotenuse, which is 50. And a and b represent the length of either one of the legs in any order, which are x and 14. So setting this up, I'm going to get x squared plus 14 squared is equal to 50 squared. And then I'm going to simplify this. So x squared cannot be simplified yet. Plus 14 squared is 196. That is equal to 50 squared, which is 2,500. Okay, and then I'm going to solve this equation to find x, which is P to Q. So I'm going to subtract 196 from both sides of the equation, and that would give me a value of 2,500 minus 196 is equal to 2,304. I'm going to move it over here. So I get x to the second power is equal to 2,304, and then I'm going to take the square root of both sides of the equation to solve for x. And we get, because that second power cancels out the radical sign, we get x is equal to 48. Okay, so the square root of 2,304 is equal to 48. Okay, so that means this side is equal to 48. Now I'm ready to write the ratios. So notice in this problem here, I'm going to write the trig ratio of the sine of Q. So Q is my reference angle. That's what we refer to as my theta angle. So for these problems, these first three problems, I'll highlight them all in green, and I'll put this right here. So that's the angle that I'm working with. That's what I'm referencing. Okay, so sine, if I'm at Q, sine is defined as the opposite leg, which would be 14, over the hypotenuse, which is 50. So this one would be 14 over 50, and you want to reduce it. We can divide both of those by 2, so we get 7 over 25. Okay, the cosine of Q, cosine is defined as, I'm working from Q, the adjacent leg, which is 48, over the hypotenuse is 50. So the cosine of Q would be 48 over 50, and then you would want to reduce this, which if I divided both of these by 2, we would get 24 over 25. Okay, the third ratio we're going to write is the tangent of Q. So here's Q. Tangent is defined as opposite over adjacent. So the opposite leg of Q is 14. The adjacent leg of Q is 48. So we would get 14 over 48, and you could divide both of these by 2 to reduce it to 7 over 24. Okay, now we're going to go over here. Now we're going to write the trig ratios for the sine, the cosine, and the tangent from angle R. So angle R, I'm going to highlight these three in yellow. So my reference angle, or some people call that your theta angle, is going to be angle R right there. All right, so now we're working from here. So for the sine of R, sine is the opposite leg. So the opposite leg of R would be 48 over the hypotenuse. The hypotenuse is 50. So the sine of R would be equal to 48 over 50, which if you reduced it, 24 over 25. The cosine of R, so cosine is defined as the adjacent leg, which is 14, over the hypotenuse, which is 50. So the cosine of R would be 14 over 50, and when you divide each of those by 2, you get 7 over 25. Remember, when you're reducing, you have to reduce both the numerator and the denominator. And then the last ratio, the tan of r, so tangent is defined as opposite leg, which is 48, over adjacent leg, which is 14, so that would be 48 over 14, and if you reduce both the numerator and the denominator by dividing by 2, 24 over 7. There's number 1. Moving on to number 2, we're going to be solving for x, and we're going to round to the nearest tenth. Okay, so in number 2, we're always focused in on which one is going to be our reference angle. So you can see here is my reference angle right here. It's that 48 degrees. All right, so now if you notice, 17 is a leg, and it is the adjacent leg. So I'm going to put an A right here. And x is also a leg, and it is the opposite leg. And I don't care about the hypotenuse here, and the reason why I don't care about the hypotenuse is because there's no information. I don't have an x, I don't have a numerical value, so nothing. So I have an O and an A. Notice in my definitions that I wrote over here, O and A show up for tangent. So this tells me I'm going to use tangent in order to solve this equation. So I write down the abbreviation for tangent is TAN. Then next to it, I write the measurement angle, which is 48 degrees. Then I put an equal sign, and then to the right of the equal sign, I'm going to write a ratio, a fraction. Opposite x over adjacent, which is 17. So this would be my equation that I'm going to use in order to solve for x. Okay? And you always set up the equation the same way. So now I need to figure out what is the decimal equivalent of tan of 48 degrees. One way to do it is I refer to my table here. So notice on the table, we go down to 48 degrees. We find 48 degrees on the table, which is right there. And then we follow it over underneath the tangent column. And you can see a 48 degree angle for tangent is a decimal of 1.1106. So I change this to 1.1106 is equal to x over 17. So what I'm saying is that decimal, 1.1106, is the exact equivalent of a 48 degree angle for tangent. Okay, and now I solve this equation. And the way that we would solve this equation is you would multiply both sides of the equation by 17. That would cancel out the 17s over there, and notice we're left with x. And then 17 times 1.1106, you can see on my calculator, I just typed that in. Well, there's a nasty glare, there we go. And you press equals, and you get a pretty lengthy decimal, and the instructions said round to the nearest tenth, so we would say 18.9. So there's your answer to number 2. 18.9. Okay, number 3. All right, so my reference angle or my theta angle, however you want to refer to it as, would be this angle right here, the 67 degree angle. Okay, and so now I'm going to use the information that I have with the x and the 29 to help me determine if I'm going to use sine or cosine or tangent. So 29 is the hypotenuse, so I'm going to use, I have a hypotenuse, and then where the x is, that's the opposite leg. So I have opposite and hypotenuse, and I look at my definitions, O and H tells me I'm going to use sine in order to solve number 3. So I write down the abbreviation, so here's how we set up the equation. You write down the abbreviation, SIN, that's the abbreviation for sine. Next to it, next to the abbreviation, you always write down your reference angle measure, which is 67 degrees. Then you put an equal sign, and then to the right of the equal sign, you're going to set up your ratio or your fraction. The opposite leg, which is x, over the hypotenuse, which is 29. So there is my equation for number 3. Now I'm going to convert a 67 degree angle for sine into its decimal equivalent. So I go to my table. Here is 67 degrees. Then I find the sine column, which is the first column, 0.9205. So the equivalent is 0.9205. That is going to be equal to x over 29. And now I solve this equation to figure out the answer for x. So I'm going to multiply both sides by 29. That would cancel out the 29s to the right of the equal sign. And I would get x is equal to 29 times 0.9205. So 29 times 0.9205, and we're rounding our answer to the 10th, so this would be 26.7. There's number 3. Okay, 26.7. There we go. All right, number 4. So number 4 here, my reference angle, or my theta angle, would be this 29-degree angle right here. So that's the angle that I'm going to reference from. Okay, please notice that x is the hypotenuse. It's across from the 90-degree angle, so I'm going to put an h there. And 12 is the opposite leg. So I have an opposite leg and a hypotenuse. I go to my definition. Opposite hypotenuse, O and H, tells me number 4 is going to be a sine problem. So it's going to be like number 3. So number 4, I'm going to use sine. So I write the abbreviation down. Then remember to set up the equation next to the abbreviation, write the angle measurement, which is 29 degrees of whatever you're referencing from, put an equal sign, and then put a fraction on the right of the equation. And your fraction is opposite leg 12 over hypotenuse x. So my equation that I need to solve is sine 29 degrees equals 12 over x. Now we're going to go to our table, and we're going to determine, we're going to go to 29 degrees, which is right there. We're going to go to the sine column, which is the first column. It's 0.4848. So the decimal equivalent for a 29-degree angle of sine is 0.4848. And I'm getting these decimals from the table. That is equal to 12 over x. Okay, now notice in number 4, when I'm solving for x, x is in the denominator, where in number 2 and number 3, x was in the numerator when I solved them out. So when x is in the denominator, this is an easy fix. All you have to do is you switch the x and you switch whatever is right here. So this means that x is equal to 12 divided by 0.4848. And whatever that equals, that's your answer. So 12 divided by 0.4848 turns out to be 24.75, and then a bunch of numbers after that, 24.8. We're always rounding to the 10th. So there we go. Number 4 is 24.8. Okay, moving on to number 5. So notice in number 5, we have a 16-degree angle. That's the angle that I'm going to reference from. That's going to be what we call our theta angle there. And then I'm going to use the fact that 37 is the hypotenuse, and this side that x is on is the adjacent leg. So I have adjacent and hypotenuse. I go to my definitions of sine, cosine, and tangent, and I'm looking for A for adjacent, H for hypotenuse. You see it right there. So this tells me, number 5, I'm going to use cosine in order to solve the equation. So I write down the abbreviation for cosine, which is COS. Next to the abbreviation, you always write down the measurement of your reference angle. In this case, it's 16 degrees. Then you'll put an equal sign. This is how we create the equation. And then we're going to write a fraction, a ratio on the other side. So cosine is the adjacent leg, which is x, over the hypotenuse, which is 37. So there's my equation. Cosine 16 degrees is equal to x over 37. And I'm going to use that equation to solve. So I'm going to go to my table, look up 16 degrees. There it is, right there. Follow it over underneath the cosine column, which is the middle column, 0.9613. So the decimal equivalent is 0.9613 for the cosine of 16 degrees. That's going to be equal to x over 37. And now I solve this equation. And the way that you would solve it is you would multiply both sides of the equation by 37. So those 37s would cancel out. That leaves me with x. And my answer is 37 multiplied by 0.9613. And we're going to round our answer to the 10th, so 35.6. So there you go. There's number 5. Okay? Number 6. Let's keep going. I'll keep going until we hit the magical 20-minute mark. We have about 5.5 minutes left for this video. Okay, so in number 6, my reference angle, also known as your theta angle, is this 58-degree angle right there. So that's the angle that I'm referencing from. I have a 22, and 22 is a leg, and it's the opposite leg. I have an x. X is also a leg, and it's the adjacent leg. So I have information about opposite leg and adjacent leg. I go to my definitions. Notice I have opposite leg and adjacent leg. This tells me this is a tangent problem. Okay, so number 6, I'm going to use tangent to solve. T-A-N. Write down the abbreviation. This is how you set up the equation. Next to the abbreviation, write down the measurement of your reference angle, which in this case is 58 degrees. Put an equal sign, and to the right of the equal sign, we're going to set up our ratio, our fraction. Opposite leg is 22 over the adjacent leg, which is x. So there's my equation for number 6. Okay, now I'm going to convert a 58-degree angle for tan into a decimal, and I refer to my table that I gave you. And this table, if you lose it, it's available online. So we go to 58 degrees. There it is. Follow it over to the tangent column, 1.6003. Okay, so I get 1.6003 is equal to 22 over x, and now I solve this equation for x. Okay, now once again, when you're solving this, and if x is in the denominator, what you do is you just switch these two values. So that means x is going to be equal to 22 divided by 1.6003. And you divide that out, and that'll be your answer. So 22 divided by, and you can't see that at all because of the glare from my light. So divided by 1.6003, my mistake, 003, we get 13.74, and that just rounds to 13.7. So there's number 6. All right, moving on, same idea. We're just going to keep doing these until we run out of time. Got about 3 minutes left. So number 7, we're going to work from the 51-degree angle. That is my reference angle there. Okay, and now let's determine what we know. So we know that we have a 15, and 15 is a leg, and it's the adjacent leg, so I'm going to put an A there. X is also a leg, and it has to be the opposite leg. So I have opposite and adjacent. That tells me this is a tangent problem. Okay, we look at our definitions here. Opposite and adjacent, T, tangent. All right, number 7 is a tangent problem. So we're going to set up our equation. Write down the abbreviation for tangent, which is TAN. Next to it, write the measurement of your angle that you're working from, 51 degrees. Next to that, put an equal sign. On the right side of the equal sign, you're going to put a fraction. Opposite x over adjacent 15. SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. We're always referring to that. Convert tan of 51 into a decimal by using your table. So there's 51 degrees. Follow it underneath the tan column, 1.2349. So tan 51 is 1.2349. That's equal to x over 15. And now when we're solving this, x is in the numerator, so I don't do that switcheroony thing that I did in the previous problem. I just multiply both sides by 15 in order to solve. So multiply both sides by 15. I'll do this off screen so I don't have to mess with it. I don't have to mess with you seeing it. So 15 times 1.2349, that rounds to 18.5. We're always rounding to the 10th in this worksheet. That is equal to, and those 15s cancel out, x. So there's number 7. X is equal to 18.5. Okay, number 8. All right, so number 8, we're going to work from the 37-degree angle. That's going to be my reference angle right here. In other words, that's what we refer to as the theta angle. X is the hypotenuse, so I'm going to use the hypotenuse, and 48 is adjacent. It's the adjacent leg, so I'm going to use adjacent and hypotenuse. Okay, I'll rewrite the definitions here. So we have SOHCAHTOA. This tells me the definitions of sine, cosine, and tangent. Okay, adjacent and hypotenuse, you can see right there, it's a cosine problem. So you would use cosine in number 8 to solve. Write down the abbreviation. To set up the equation, next to the abbreviation, you always write the measurement angle, which is a little hard to see. I think that's a 37 degrees. Let's go with it. It might be 32, 37 degrees. Put an equal sign, and to the right of the equal sign, you always write fraction. And the fraction is the adjacent leg, 48, over the hypotenuse, x. There's my equation. Go to your table, find the decimal for the 37-degree angle cosine, so there's 37 degrees. Cosine's the middle column, so 0.7986. So 0.7986 is equal to 48 over x. And now, if x is in the denominator, remember to solve for it, you do the switcheroonie. So that means x would be equal to 48 divided by 0.7986. Okay? I can show you why that works if you really want me to. Stick around at lunch after school, before school, and I'll show you why that switcheroonie works. But if you're happy with it and you have no reason to believe me that I'm not telling you the truth, just do it. So 0.7948 divided by 0.7986 turns out to be 60.1. So there's your answer to number 8. Okay? And we've hit the 20-minute mark. We're out of time. So you're on your own for numbers 9, 10, 11, 12, 13, and 14, and 15.